All right, welcome back everyone to learn.py. I'm Anar and I'm here with Nari today. And we're gonna be covering data structures in Python. So yeah, let's get into it. So yeah, first up, if you want to link to the slides, there it is. Oh wait, there's a typo. It's not .coxm, it's .com. I don't know what happened there. Yeah, so we're using a new website, links.ucla.acm or .com. So yeah, check that out. And then the README is also there if you want to check that out as well. Okay, and our membership portal attendance code is I love you, Guido Rossum, because you're going to find yourself saying that a lot throughout the workshop. That is the original designer of Python. So yeah, let's use that. And also our feedback form, please fill it out. We really appreciate your feedback. We do take into account, you know, the spiel. And of course, there's always the raffle to keep in mind. So yeah. All right. So last time we talked about, you know, some basics of Python, like fundamentals, functions, data types, stuff like that. This week, we're going to get into data structures, like I mentioned. Here's just a quick overview. So first up, we're going to talk about sequences, then tuples, then list comprehension, and finally, we'll talk a bit about lambdas. And then we'll have a quick break, and then we'll get into stacks and queues, collections, sets, and dictionaries. So all that is very exciting. So let's get going. Oh yeah, and as always, if you have any questions, please ask. Don't be shy. Honestly, unmute yourself, interrupt me. I will very much appreciate it if you ask questions. I don't want to have you guys sit there and be confused, okay? I'm sure if you have a question, someone else also has the same question. So just step up to the plate, be that guy, and I'm sure people will appreciate it. Okay. So yeah, ask your questions, please. But all right, let's get into it. So last time we talked about, one thing we talked about was lists. And we explained that they're a container type, right? Similar to resizable arrays in other languages, right? And one of our key takeaways was that they are a mutable type, right? And just as a quick reminder, mutable means that they are, you can change them after initialization, right? As opposed to an immutable type would mean that you can't change them. So lists are by far the most common structure that you use to store data in Python, but there are a lot of alternatives to lists. So today we're going to just take a look at some of those alternatives, as well as some of the use cases of them, some of the implementations, and some really cool Python-specific features that they have. So yeah, first though, we're just going to get started with sequences, which are essentially the foundation to all ordered data in Python. If you have ordered data, you have a sequence, right? So I guess I kind of answered my question before I asked it. What is a sequence? It is just a group of some items, some elements that have some order associated with them, right? So with that definition, it's pretty clear that a list is a sequence, right? So a list is what we just talked about, those array type things. The strings are also sequences in Python, and also ranges, which are those things that are returned by the range function that we looked at last time with the for loops, right? So those are all sequences. And just to reiterate, these are all sequences. This is a list here. It's ordered data. It's a sequence. This is a string. It's ordered characters. It's a sequence. This is a range. It's ordered numbers. It's a sequence, right? Okay, and the Python developers, they love you a lot. They want to make your life as easy as possible. So what they've done is they've gone and made a common set of operations for all sequence types in Python, which is really, really convenient. You will learn to appreciate it a lot. So as an example, last time we talked about how you can multiply strings in Python, right? So here's an example of that. Python goes b plus r times 10. That just, the result of that is Python goes brr, right? So you can see that multiplication happening. That just adds r to itself, or concatenates r to itself 10 times, right? But it turns out that that is not a string specific feature, right? That is a sequence operation. So that can be done to any sequence type, not just strings. So yeah, there are a ton of other common operators between all sequences. Here's just a quick table of them all. So as you can tell, there are a lot, and there are even some beyond this. And unfortunately, I don't have time to cover them all in depth, but I will be highlighting just a couple that I find pretty interesting, pretty useful. So first up, the in operator. I'll be covering that. And then I'll be talking about indexing, which you're probably familiar with from other languages. I think we talked about it last time too, actually. And also we'll be talking about slicing and splicing, which are two separate things, by the way, slicing and splicing. So yeah, we'll talk about those things. Okay. First up, the in operator. So very often in our programs, we want to determine if there is a certain value in a sequence, right? So pretty much exactly what you would expect from the name of the operator. So say, for example, you want to determine if 42 is in a list called meaning of life, right? You could just use a loop, which is the typical approach you would take in other languages. So you could do something like this. You would iterate over all of the items in the list, check if the current item you're iterating over is 42. And then if it is, you know that 42 is in the list, right? You could do that, but you could do better with this in operator, right? So it's pretty simple. All you do is you just use the value you're looking for. You say in, oops, you say in, and then you have the name of whatever sequence you're searching in, right? So if 42 is in meaning of life, then this returns true, and then this will print 42 is in meaning of life. If it's false, if 42 is not in meaning of life, then this will be false. Is in just performing the loop for you? I believe so. I'm not entirely sure. Maybe someone can correct me on that, but I'm pretty sure it just converts it to, like, it's just an operator that calls like some function probably and performs a loop. So yeah. Okay, so that looks pretty nice. That's some nice syntax. But let's do some examples of that. So let me just fire up the interpreter here. So I'm just going to type in Python 3. That will open up the Python interpreter. And then I'll do this really quick, just fire through it. So false in. So I'll just put a couple random values here. Hello. Okay, does anyone have any ideas what this will evaluate to, true or false? Just drop it in the chat. True. Why do you say true? False. Okay, we see some disagreement. Okay, yeah. Okay. Yeah, okay. So it is false since flu. Yeah. So it's false since this is a string, right? It's not a Boolean. This is a Boolean, so you can't, a Boolean is not equal to a string. So this is going to be false. Alternatively, if I said false without the quotes, that would be true, since false is in this sequence, right? And just to show that this is valid for any type of sequence, not just a list, I'm just going to do this. Structures. Any ideas on this one? Is this true or false? True. Yeah, it is true. Since ruct, you can see this substring is contained, or this substring ruct is contained right here, ruct, right? And one last one, just to show that it works with ranges too, range 1 to 100, counting by twos. So this is a range of all the odd numbers from 1 to 100, right? Is negative 99 in that range? No, it's not. So that's going to be false, right? So that's a really cool feature of Python. You're already like, this is like, honestly, this is the most basic thing we're going to do today, and it's already like really cool. So yeah, buckle up. Yeah. Yeah, I think that's basically it for the in operator. Let's move on to our next thing, which is indexing. So you're probably familiar with indexing. So indexing just returns a certain value within a sequence in Python. So you use the square bracket operator and some integer within that operator, right? The one different thing though is that you can also use negative values to retrieve items from the opposite end of the sequence. So if you want the last item in the sequence, you can use square brackets -1, right? So that's pretty cool. I'll show some examples of that. So yeah. One difference to note is that you can have out of bounds errors in Python, which is really nice coming from C++, right? Where they don't tell you when you have undefined behavior. So we love that. Thank you, Python. And here's just a look at that indexing. So as it is in other languages, the start of the array starts at 0. So 0, 1, 2, 3, 4 to reference each item. Alternatively, you could use negative numbers to reference each item. So from the opposite end of the sequence, it's going to start with -1, -2, -3, and so on. So yeah, let us take a look at some examples. Again, really quick, I'll speed through this. Let me just clear this and paste that in. So if I do L1 of second index, then that will return -3. That's nothing new. That's what we know. If I do L1 of -1, that will return the last item, right? So -1. And again, like I mentioned earlier, you can have out of bounds errors. So if I do something like this, let me just get 1, 2, 3, 4, 5. 5, the size of the sequence is 5, right? So this is going to have an out of bounds error. There is no index, there's no element at index 5. And also if I do something like this, wait, no, I think -6, right? -1, -2, -3, -4, oops, -5. So that's going to be out of bounds since there is no element at the -5th index, right? So yeah, that's basically indexing. Now let's move on to slicing and splicing. So what exactly is slicing, first of all? It's basically just a concise way to get a sequence, right? So yeah, I'll show an example of that in a second. And I do want to comment on the difference between slicing and splicing because it was something that tripped me up a bit. So slicing is when you just want to reference a subsequence, right? You're not actually changing anything about it, you're just looking at it. Splicing is when you are actually modifying that subsequence. So say you're like completely getting rid of it, or you're replacing it with something else. That's called splicing. So yeah. And you can only splice if your sequence is mutable, obviously, because you can't change a immutable sequence. Okay, so some examples. I'll show you the syntax. that would probably be helpful, right? So let me just copy paste that in there, and I'll clear it too. So L2 is going to be this guy up here, and then if I do something like this, L2 from the second index colon up to but not including the 6th index. That's what the syntax means. So it's going to start including the second index, right? 0, 1, 2, and then 3, 4, 5, 6, up to but not including this. So let's see what that does. And you can see, just like I said, 2, 3, up to 5, not including the 6th index, right? So that's, again, another really cool feature. But it goes a step further, and we'll see that in a second. So here is the general syntax of that. So you just have 3 integers. So I, j, k. You notice I didn't include k before, and I'll explain that in a second. So in this case, I is going to always be the inclusive start index. Like I showed you, I is going to be included in your subsequence. And then you have colon and then a j. J is going to be your exclusive end index. Again, you saw that before since the 6th index was not included, right? This guy over here was not included in this subsequence. Then we have k, which is going to be something called the step. So it's basically if you want to do something like every other item in the sequence, you could do you could set k equal to 2, right? So that's another really cool feature of that. And since you saw before, I didn't include k. And if you don't include one of these, they all have default values, right? So k's default value is just going to be 1. It'll be the step of the sequence is going to just be 1, right? But you can also have I have a default value and j have a default value. So let's take a look at that over in our VS Code here. So let me just copy paste this again. Here we go. let's say I want to leave I want to leave I blank and also K blank. So I do something like this. In this case, the default value of I is always going to be 0. So it's just going to start at the beginning of the subsequence, right? So it'll go from 0 up to, but not including the second index. So let's take a look. Oops, I used the wrong one. Let me just retype that really quick. There we go. So yeah, you saw it 0 and 1. And then you can also leave off K, but not I. So you can just do something like this. And that will, the default value of K is always going to be the end or the size of the sequence, right? So it'll go from 2 all the way up down to the end, right? You can also just leave off all of them, just have nothing. And then in that case, it'll just use all default values. So it'll go from 0 all the way to the end of the subsequent, or all the way to the end of the sequence, counting by ones. So there you see that that's just an easy way to do or to make a copy of a list, right? So that's pretty cool. You can also leave off if you want. Oops, I'm typing the wrong place. You can also leave off all of both I and J and only include K. And to do that, you just have a double colon and then just whatever you want. I'm going to type 2 there. And you can see that that prints every other item in the sequence, right? So, oh my God, I'm in the wrong. Okay, that was weird. Okay, so yeah. You can see I just iterated over every other item in the sequence, right? 0, 2, 4. Sorry, I just realized I showed you a sneak peek of the demo, but it doesn't matter. So yeah, every other one, that's what the step is used for. Also, another really cool feature is you can have a negative step. So I do something like this. That's just a really quick and easy way to reverse the list, right? So you can see up here, it's 0, 1, 2, 3, 4, 5. Down here, 5, 4, 3, 2, 1, 0. Really cool. You try doing something that concise, or try reversing a list that concisely in another language, you can't do it. So yeah, it's awesome. All right. So I think that's enough examples of that. Oops. So if you take anything away from our discussion here, just let it be that sequence types in Python all have common operations to them, right? And I can't cover them all, so I do recommend you check out this documentation here. I will show it to you if you want to see it. So it has all these operations you can do. Also, there are a few more down here that only apply to mutable sequence types. So you can see some splicing going on here, some splicing going on here, some cool stuff. So check that out. And yeah, okay, here we go. So yeah, I do recommend checking out the mutable section. There's a lot of really cool stuff. Yeah, C++, CS31, 32 scarred me a bit. Like yeah, I hate them. Yeah, so, okay. Actually, I do want to pause for questions here because I know that was a bit of stuff. Are there any questions on sequences, operations of sequences, any other general stuff, whatever you want? Okay, awesome. So let us move on to tuples, which are another sequence type in Python. They're really similar to lists. So they're just a general sequence of some elements of any type, right? And they're implemented as a typical C-style array. So that means that they're not resizable. And there are some additional optimizations. I'm not going to get into it today because it's kind of dense, but I do have it linked on the slides if you want to read it and you're interested. And the one difference, and this is a big difference between tuples and lists, is that they are immutable, right? So that means you can't reassign any elements within them. You can't remove any elements. You can't insert any elements. It is set in stone after your initialization, right? Note that it is possible to reassign mutable objects within a tuple. So say you have a list of tuples, or a tuple of lists, right? You can change the elements within those lists since they are mutable. But yeah, so here are just here's a look at the syntax for declaring tuples. So one way is to just surround your values with parentheses here. So you see 1, 2, 3, 4, surround in parentheses. Alternatively, you can just leave off the parentheses completely and just have some comma separated values. That works too. That's interpreted as a tuple. But if you want a empty tuple, you do need to include the parentheses. Otherwise, how would Python's not going to know what you're trying to do, right? You just have an empty space there. And also to declare a single element tuple, you have to always have a trailing comma here, right? So that's that guy. Okay, but I know what you're thinking. It is, why would I ever want to use a tuple over a list? Lists are 100 times more flexible. They're so much more convenient. Why would I ever use a tuple, right? Short answer is for optimization reasons. Tuples take up a lot less space than lists, and they're also, they can be initialized significantly faster than lists, right? And that's just because of all of the overhead that comes with mutability of lists, right? So, for example, like the resizing aspect of it, that comes with a cost, and also all of the functions that you saw that I just showed you with the mutable sequences, that also adds some overhead. So tuples get rid of all that. They cut it down to the bare minimum. So they are pretty optimized compared to lists. So as a result, if there's ever a case where you know that you're not going to change any items within a sequence, just consider putting them in a tuple, just for the sake of optimization, right? And by convention, tuples are very often used for what are called heterogeneous sequences, right? So that just means a sequence of some different types, right? So if you have a sequence that has, a string and some integer in it, just by convention, people use tuples for that kind of thing. So yeah. Okay, let's move on to something that's pretty closely related to tuples, and that is sequence unpacking. So sequence unpacking is just a way to directly assign all elements of a sequence to variables really quickly. So for example, let me just show it over here. Let me clear all this stuff. So I do something like this. So I'm declaring a tuple right now and putting the values A, B, and C in it. And then I can really quickly and easily assign these values to variables by using this syntax here. So this is what sequence unpacking is. So now you can probably guess that X is going to have the value of A, Y is going to have the value of B, Z is going to have the value of C, right? So let's just verify that, X, Y, Z, and you can see A, B, and C are printed. So that's pretty cool. And this is not limited to just tuples. You can also do it for lists or any other sequence type. Again, this is all common. This is a common operation, right? So let me just showcase that. Actually, I will, oops. Yeah, here we go. I will just do this. Okay, well, you get the idea. You can do it with lists too, okay? I don't feel like wasting your time right now. Okay. Yeah, so this is just some syntactic sugar. It's really nice, it's really fun, really convenient. So here's some use cases for that. So again, like I just showed, you can assign multiple variables at once, really concisely. So just say A, comma B, comma C equals 1, 2, 3. This is technically a tuple, right? It just doesn't have the parentheses around it, but it is basically just sequence unpacking, right? And something really cool is you can really easily swap variables, the values of variables, without needing some temp variable. So yeah, goodbye temp, I don't need you, you're gone. So yeah, really, really cool stuff. Okay, any questions on that? Okay, I don't see any questions yet, so let us just keep going. All right, so let's go on to a demo. So I'm gonna pop over into VS Code here. Let me just close down the interpreter and shrink this a bit so it's not in my way. Okay, so you can see the problem statement up here. You can read that if you want, but I'll also just explain it. So we want to write a function that, given two lists, is going to return a list of every possible pairing of elements between those two lists. So that might be kind of confusing. So let's just take a look at an example. So given these two values, L1 and L2, the return value of this function would be 1, 3. So 1 is paired with 3, and then 1, 6, 1 is paired with 6, 2, 3, 2, 3, and so on. And also we're going to add one restriction, which is that given each pairing, each element has to be distinct. So you can't have, for example, 3 paired with 3, right? And you can see that that's reflected in this list here. Is this FOIL? No. This is called, actually, it's kind of similar, but no. It's called the Cartesian product, if you care. So that's why I called the function cart product. So let's write it. So there are a lot of ways we could approach this, but let's just take the most obvious route first, and that's just using loops. So I'm going to declare a function, call it cart product, and it's going to take 2 lists, right? L1 and L2. And then we're going to be building a list throughout the function, right? So I'm just going to declare an empty list right here, and I know I want to return it at the end, so I'm just going to do that. And then I can, here, sorry, let me just make this a little prettier. Here we go. So to make every possible pairing, to make a list of every possible pairing, what would we need to do? Well, first of all, we're probably going to have to iterate through every item in L1, right? And then we're probably, for every item in L1, going to have to iterate through every item in L2. So that's probably just going to be a nested loop, right? So let's do that. So for L1 in, oh no, not for L1, for I in L1. So this is iterating through every item in L1. And then we want to iterate for every item in L2. And then since this restriction is up here, we have to check that I is not equal to j. So let's just do that really quick. If I is not equal to j, oops, I did not mean to do a semicolon. Okay, so since if this is not true, then we want to append a tuple. As you can see, that we expect tuples based on this declaration up here. So I'm just going to add a tuple of the pair I and j, right? So this is just going to do exactly what I say up here and make a list of every possible pairing. Let's check that it works. I'm just going to print cart product of L1 and L2, which I have up here, are basically just the same thing that I have here, right? So let's make sure that this works. That is not what I wanted to happen. Oh yeah, Python 3 of demo.py. So I'm just going to run the script. Here you go. So you can see it looks like it worked. There is no, all the pairings are distinct pairings, and it looks like they're all accounted for, right? So that's pretty cool. And it technically works, but it's really ugly to look at, in my opinion. There's all this indentation. It's on like 10 lines of code. I think we can do a bit better than this. So let's explore some other options, right? And that other option is called list comprehension, okay? So list comprehension is a very concise way to generate a list based on some other list. And it's very readable, it's very elegant. And here's just a quick look at it. It might be kind of intimidating at first, all these words, all these keywords, you know. But once you get it down, you will love it. I promise. It's very, very intuitive. So let me just copy paste this syntax into here so you can remember it pretty easily. I know it's a lot. So what I'm going to do is I'm going to transform this to use list comprehension, right? So let's get started with that. So first up, I know that I don't need an well, you might not know, but I'm telling you, you don't need an intermediary value when you're using list comprehension, right? So I'm just going to get rid of this, and I'm just going to return something here. You can see that list comprehension, you surround it. The way you indicate that you're using list comprehension is you just surround something with square brackets, right? So since I'm just directly translating this, I can just pretty much copy paste directly. So I have, this is my for iterator and iterable. It's going to iterate through L1. And then you can also nest these for loops here. So I can do the same thing and just copy paste this down here. Boom. So this is going to behave exactly the same way. It's just a nested for loop, right? And then my condition is down here. Just get that guy in there. And then boom, all we're missing now is the expression, right? So I can just get this guy and copy paste them right there. So what this is going to do is basically exactly the same thing as this. It's just going to iterate through every item in L1. Then for every item in L1, it'll iterate through every item in L2. If this condition is met, if I is not j, then it'll add this expression. It'll evaluate this expression and add it to a new list that we're generating. So let me just get rid of all this stuff. We don't need it anymore, right? So you can see we went pretty quickly from like almost 10 lines of code to literally just one line. Pretty nice, if you ask me. So yeah, really cool. And yeah, so it's definitely possible, actually, I should mention this, to go overboard with list comprehensions and make it completely unreadable, completely like, hard to look at. So make sure you don't get too carried away with all this power. But yeah, it's nice to know that they're there when you want to use them. So yeah, by the way, I just want to verify that this works, so I'm not telling you, so you know that I'm not lying to you. Don't say it. Don't say it, Eugene. Yeah, so this works. So yeah, let's go back to the slides. Okay, I want to talk about one more thing, and that is lambdas. It's a little bit disjointed. Side note: what is the Visual Studio theme? I believe it's called. Well, I'm sorry, Eugene. You can finish your thought. I was just kidding. The Visual Studio theme is, let me just Noctis Lux. So I think it's an extension. I don't remember. I installed it a long time ago. So yeah, check that out. When have I ever shut you down, Eugene? What are you talking about? Okay, let me get back to the workshop. I'm sorry. Okay, so one last topic. This will be quick, and that is oh wait, any questions? Any questions on any of this? Okay, I'm gonna just assume there are no questions. So let's go on. So lambdas. This is not a data structure, but I did want to talk about it today because it's interesting and I think that you should know about it. So yeah, there you go. So lambda is just a small anonymous function. And by anonymous, I mean that it doesn't have a name, right? So as compared to like a normal function that looks like this has the name sum, right? Lambdas don't have names by default, at least. So let's take a look at the progression and syntax from the def function, the standard def function, to a lambda function. And just a quick note is that none of these intermediate value functions I'm going to show you are valid. So only the first function and the last function I show you are going to be valid. So just keep that in mind. But okay, let's get started. So oops, I told you that they're anonymous, right? So right off the bat, I'm just going to get rid of the name. So you can see I took off sum here. Oh, and by the way, it's not clear. Sum is just a function that takes 3 values and returns their sum, right? So yeah, so I got rid of the name there. That's one step in the progression. Then to indicate that it is a lambda expression or a lambda function, I am going to replace def with lambda. And then another step, you can just leave off the return statement. You don't need it with lambdas because Python just infers that this is what you're going to return. And then you can just put this all in the same line. So yeah, just move this guy up here, and then you get this. And if you want to, there's one last step. It's optional, but you could just get rid of these parentheses just for a nice clean look, no parentheses, ABC, colon A plus B plus C. So this and this are going to do the same thing. They take in 3 parameters. So these are the parameters down here. And then the colon indicates what's after the colon indicates what you're returning, right? Okay. So, and like I mentioned last workshop, actually, functions in Python are first class, right? So they can be passed around, they can be assigned to variables. So yeah, this opens the door for a lot of interesting behavior which are used in like functional programming languages. So yeah, it's pretty cool. Python is multi-paradigm, but I will talk a bit more about that later. So yeah, this is the final syntax. And one important note is that these are only small functions, right? So you can't have some big complicated return value here. You need to limit it to one expression, otherwise you'll get a syntax error. Just because I think the Python developers wanted to keep these simple, they didn't want people to get too carried away. So yeah, keep that in mind when you're using lambdas. Okay. Okay. So like I mentioned before, Python is a multi-paradigm language, right? So that means that you can use it in a lot of different ways. So one of those ways, like I mentioned, is a functional approach, right? So you can use these functional techniques, such as passing functions around to other functions. You can pass them to other variables. That's all really cool. It's all really fun. But there's also what you're used to with the object-oriented approach. So you can also use object-oriented approaches in Python, right? But that is not the topic of today's workshop. That's the topic of next week's workshop. So you're just going to have to watch next week. So yeah, I think that's pretty much it for my section. Yeah, let us just take a quick break. How long should we go? I think like 7 minutes. What do you say?
10 minutes is fine.
Oh yeah, 10 minutes, sure. Let me mark it down right here. So 6:51. Yeah, okay, so do you want to share, do you want to like put on some music, Nari?
Sure, stop the recording since it's free.
Oh yeah, sure.
All right, so we've gone over lists, but let's look at some more container types that are pretty awesome, in my opinion. So this meme is kind of funny. Yeah. All right, so what we'll be looking at first is stacks and queues. And stacks and queues are structures that allow us to keep track of our data in a particular way using lists. So stacks and queues on their own are not their own like actual structure within Python, like a built-in type, but they are rather concepts that are used pretty frequently and are really important to know. So stacks and queues are usually listed together because they're similar in concept, but they work fundamentally different. So first, let's see what a stack is. So a stack is a structure where the elements are inserted, the elements that are inserted first are removed last. So in shorthand, we would call this LIFO, meaning last in, first out. And you can think of it like a stack of flapjacks or a stack of dishes, for example. You put each flapjack on top of the other one, and then whenever you want to eat them, you'll eat them from top to bottom one by one. Unless you eat them all at the same time, though don't know why you would if you have a big stack. But yeah, so let's see how LIFO is actually applied. So I can add any number, and as an example, we can observe the way that they're added and removed. So in terms of like semantics of what we call adding and removing things from a stack, when we add them, we say we push things to a stack, and removing means we pop it from the stack. So for example, I'm going to push a couple numbers onto this stack here. So at the bottom, we'll have -5, then 4, then 1, then -2. And now if I want to pop my stack, that means I want to remove some items from the stack. We'll now go from top to bottom, -2, then 1, then 4, then -5, and then our stack will be empty again. And in a similar concept, a queue is a structure where the elements that are inserted first are also removed first. So we call this FIFO, first in, first out. Again, another shorthand that we use often. So think of it like standing in line at a store. If multiple people are waiting at the checkout line, the first person, so the person closest to the cashier at that moment, will be the person who will be checked out first. So again, like stacks, let's see how FIFO is applied. So we don't call it pushing and popping with queues. We call it enqueuing and dequeuing. So let's enqueue some items. So let's put -5, 4, 1, and -2 again. And you'll see we go from left to right. But when we want to dequeue items, so when we want to remove some values, the first items that were inserted will be removed now. So as we'll see, -5 will be gone, then 4, then 1, then -2. So why do we use stacks and queues? So they have many applications, but just on a basic level, you can use stacks for things such as an undo in a text editor or a back button in a browser or anything where you need to track the order of previous operations. With queues, they can get a little bit complex. For example, within a CPU, all of the operations are kept within a queue so that the CPU knows which order to go in with the operations. But generally, any time that you need to keep track of the order that things come in, you would use a queue. So one fun activity you can try at home after this workshop, and just think about it. You can think about how you might implement a maze solver. So if you're given a maze between a stack and a queue, and as you'll see, they end up getting different methods to get the same answer. But that's just a fun little activity. So how do we actually use lists as stacks and queues? Because right now it's kind of abstract. So let's hop into idle, which again is our little Python interpreter that you can launch. And let's look at some examples. So I mentioned that stacks and queues are implemented as a list, meaning we can just create a simple list and, and now we're going to treat it like a stack or a queue. So first we're going to use a stack. To push items onto a stack, we'll still use the same operations as before with the list, where we can append. So let's just add some cool letters to the list. And I just click tab there so that I don't have to type out cool letters. So I'll just append n, for example. And I'm just going to up arrow and enter to get this line back so I can quickly edit it rather than typing the whole thing again. But I'm just going to add a couple letters here. So just like some basic stuff we went over last time with lists to add to the list. So we've pushed some items onto our stack. So let's actually see what's different about it. So when I want to remove items from this list, as a stack, I can use something called pop. And what it will look like is, if I type it here, .pop. And we're not going to pass any parameters with it because by default, it'll just pop the last item in the stack. And that's how a stack operates. The last one that was entered will be the first one to leave. So if we do .pop, we'll see that it returns a value. So pop always returns some whatever item was recently popped. You can also store that in a variable as well. And if you were doing this in some sort of Python IDE or something in text editor like VS Code, you will have to store it in a value to use it in the future. So if I want to store it in current fave letters, like just some string variable, I can do cool letters.pop. And if I print current favorite letter, I'll see that it contains B, which was the second item that we added. And we can see that it doesn't automatically make cool letters into something called a stack because there is no stack type. It's just how we treat the list that makes it a stack. So if I pop it again, we'll have an empty stack. So let's pop the stack. And if I try to print cool letters, we'll see that it's currently empty. And what will happen if I try to pop it again? Of course, there's nothing to pop. So what we'll expect is an error. So that's something you want to keep in mind. Whenever you pop items in a stack, make sure that it is not empty. So now that we've seen this with stacks, let's see it with queues. And queues will operate in a very similar way. But so just as an example, let's do fave fruits. And I'll just put some fruits in here. So strawberry, and orange, and watermelon. So again, just a simple list, but we're going to treat it like a queue. So if I want to dequeue items, then I have to use the pop function. But if you recall, passing no parameters within pop will automatically pop the last item in the list, in the stack. But for queues, we want to pop the first item or dequeue the first item. So we still use a function called pop. But instead of just leaving it with no parameters within the parentheses, we're going to put 0. And remember that lists are indexed from left to right, starting at 0. So 0 will pop or dequeue the first item in the queue. So as we see, strawberry was outputted, but if we print favorite fruits now, oh, oops, forgot to print parentheses. All right. If we print it now, we'll see that orange and watermelon now shift up a space, if you want to think about it like that, where orange will be the next in the queue. So again, just want you to keep in mind that, like, again, if I'm popping it, you do want to put it in a variable typically, but since I'm just in idle, I'm just going to pop it so we can see the value. Are there any questions at this point before I go into more operations? I did not have chat open, so that's why I pause for a second. I don't know if strawberry and orange and watermelon would be good pizza toppings, but you know, sure, we can try that one day. Okay, so let's go to some more operations. So let's clear the queue itself. So let's just pop everything again. And now I'm going to pop one more time to get rid of watermelon. And as we expect with stacks, if I just pop, we should get an error because there's nothing else in the list. So again, with stacks and queues, you just really want to be careful to not pop an empty list. So those are some basic operations. Of course, implementations of stacks and queues can vary. And by that, what I mean is however you decide to use it may vary, but these are some basic operations that you can do to implement a stack or queue. So let's go back to our slides. So I just want to mention one thing about queues. Typically, we don't actually use lists to make and operate on queues because, for example, popping items out of a queue it's usually pretty inefficient. I just use a list just to demonstrate the concept if you've never seen it before, since we don't expect you to know some data structures coming into this. But what we use instead of a list for queues is something called a deck. And it's spelled like, it looks like DQ, but we pronounce it deck to differentiate between the operation that you do on queues and this data structure. And it works very similarly, but it's implemented differently. So if you've taken CS32 before, or any kind of equivalent class or know about data structures, if you've heard of linked lists, that's how a deck is implemented. But if not, don't worry about it. Just know that deck is typically how we use a queue. I won't cover it within these slides just for the sake of time, but I highly encourage you, once you understand a little bit more about stacks and queues and want to delve deeper, feel free to check the README where I've written like a bit of usage and examples with deck. So I know I paused for questions a couple seconds ago, but again, any questions so far about stacks and queues? Okay, looks like we're good to go. So let's get into the last main section, but the last few data structures that we have. So let's talk about collections now. We mentioned sequences in the first part, but collections are a whole different type of data structure, although they're similar to sequences in the sense that they also hold data, but they're a little bit different. So one point of contention, or one different thing between collections and sequences, is that collections don't use deterministic ordering. And that's a fancy way of saying whatever you input will not stay in the same order that you added them. I will make a note of this later for each of the types that we talk about. which will be sets and dictionaries. But just keep in mind that they are not the same as sequences with the way that they operate, but they also hold data just in their own way. And the two types that we would talk about are mutable. So first, let's talk about sets. So a set is a type of unordered collection, meaning whatever order that you insert items will not stay in that order. And it does not allow for duplicate items. So if you insert many of the same value, it will only have one instance of that value. So to create a set, there's two ways to do it. You can either create a set by using the set with two parentheses, and this is necessary for empty set, as we'll see in a little bit. Or you can do my set name, so any variable name, and it equals, and you can already initialize some values. Instead of the braces or the brackets that we used before, we use curly braces now to denote a set. And of course, with all data types, there are some operations that we can do on it. So there's some mathematical operations that we can perform that are inherent to sets. So let's say we perform these on my set and my set 2, just some two arbitrary sets. One thing that we can do is a union, where the resulting set that you get from taking the union of these two is all of the items within my set and my set 2, both the unique ones and their shared items. Of course, if there's any shared items, they will only have one instance of it in the resulting set. Another type is intersection. And with an intersection, the resulting set is all of the items in my set and my set 2 that are shared amongst those two sets. So only the ones that are shared between them, none of the unique items within each set. And finally, last two we'll go over for this time is resulting difference, in which the resulting set is all of the items within my set that are not in my set 2. So any of the shared items or any of the unique items within my set, so none of the shared items. And symmetric difference is the resulting set of my set and my set 2 that are in one or the other, so all unique items, but none of the shared items. And if you've used sets in math before, these will look very familiar, but if not, we'll get into some examples in a little bit. So why should we use a set over a list, for example? So there's many reasons, and of course, different data structures have their own use cases, but in general, you use sets because they're faster than lists if you want to check if a certain item is contained within it. So if you just simply want to have a container and see, is this item within this list, sets are usually faster for doing so. But again, just remember that they can only contain one occurrence of an item. So just some more set operations, and we'll see some of these examples in a little bit. To add an item to the set, you can do set underscore name, or well, you don't have to do set underscore name, but you just do whatever the set name is and do dot add and then whatever value you want to add. And just with, for example, with lists, you're able to add items that are of different types. To remove a certain item, we have two methods, and there's discard and remove. And you may be like, why are there two different methods? Well, they act a little bit differently, even though they do the same action, but they act a little bit differently. So the main difference to keep in mind is that if there is an element that is not within the set that you're operating on and you try to remove it, remove will give you an error for trying to remove it, while discard will not. It will just simply not remove it. You can also use pop, but it will just remove one random element from the set. All right, so let's set your knowledge in place with some examples. So let's go back to idle, and I'm just going to leave some blank lines here. And let's start off by making a set. So I'm just going to make a set of numbers. And remember, we can use curly braces and already put values in there if we want. So we don't use brackets anymore. So I'm just going to make multiple occurrences of 33 just to demonstrate that only one of these will be stored in it. But of course, I'll also add some other numbers as well. Okay, and if I print nums, as you'll see, they're not in the order that I inserted them, but there's only one occurrence of the multiple 33s that I put in as well. But all of the items, of course, that I put in are also there. So we used the in operator with sequences, but you can also use it for collections. So if I wanted to check if a value is in nums or my set currently, just do 33 in nums and it'll return true if it is. Of course, if you run something that is not in the set, so like 70, it'll return false. And so I mentioned the set function as well. So this function, there's many uses as well, one of which being creating an empty list. But something really cool that you can do is, let's say I have a set X and I want to put each letter of a string into its own element within the set. I can use the set function to do this. So if I just do X equals set and then in a string anar, and if I print X, we'll see that each letter is put in there. Of course, it's not in order. Really, there's no order to it because sets are unordered. So I'm just going to do that with my name as well. Oh, sorry, I forgot to close the string. Okay. And now if I print Y, you'll see all the letters in my name are their own element within the set. So let's do some of the set operations that I showed on the slides. So for union, you use something called a pipe. And what the pipe looks like is like this. If you haven't used it before, it's above the enter key on an ANSI layout. If you have an ISO keyboard, it's a little bit on the side, but I'm assuming most of you will have ANSI, so that will just be like the flat rectangular enter key. It's right above it where you usually click backslash and you just do shift and the backslash key to get a pipe. So if you do X pipe Y or X union Y, you'll see that the resulting set is all of the letters in NAR and all of the letters in ANAR, including the unique and ununique ones, or the ones that are shared amongst them. And there's no repeats. In a similar vein, we can also do X and Y, and this is intersection. So any of the items that are shared within our sets. So there's quite a few letters that both ANAR and I share within our name. So if I do and, which again, just for clarification, is shift 7 on your keyboard, and you'll get all the numbers or any values that are shared between the two sets. Now, if we look at difference, we just do X minus Y, or you can also do Y minus X, but order does matter. So what we're saying here is give me all of the elements within X that are unique to X and are not shared within Y. So the only letter in my name that's not shared with ANAR is the letter I, or ANAR's name that are not in my name is I. We can also do it in the opposite order, of course, and we'll get H because H is not in ANAR's name while H is in my name, but NARE within my name is in ANAR's name. So that's for differences. As far as symmetric difference goes, we use something called a caret. So this will be shift 6 on your keyboard. And what that means is give me all of the elements that are unique to both X and unique to Y, but none of the ones that are shared. So since we know that I and H are unique, we can expect that H and I will be within our set. And just as one final note, as far as these operations go, if you want to actually do the operation on the set, so I want to say I actually want to store this operation on the set of X union Y. If I want to share it with store it within X, I just put an equal sign after, and if I print X, we'll see what we had before when we just did X union Y. And you can do that with all those operators that listed above. So that's as far as the math part goes. So as far as the actual usage of sets, there's a few more. So one cool thing that you can do using loops is if you want to populate a set, one thing you can do, and I'll just write it out and explain it afterwards. So let's say I have a set A, I can put x for x in Kesha if x not in shell. All right, this is a chunk of a statement, but what does this actually mean? So we're saying I want to put all x into a set, okay, but what is x? So x is in Kesha, for x in Kesha. We know that means for all of the letters within Kesha, if x is not in shell. So what we're saying is put all the letters in Kesha that don't appear in shell. So we know CHE is shared between Kesha and shell, so all the letters that will be in it, and if we print A, are just A and K. So that's one way, and of course there's different ways you can use this kind of set population, but this is just like a simple example of that. And we talked about discard and remove, so let's just do discard and remove really quickly. So if I have my set nums again, just so we can print it here and see what it was before, we have these numbers within the set. If I do discard, and let me just do it, I can do discard, and I put the value that I actually want to remove. Remember that sets aren't ordered, collections don't have indices. So I can't actually use some sort of index to say remove this value. I have to put the value itself in there. So if I discard it and I print nums again, we'll see that 40 is no longer there. But if I do nums remove and do 50, it should do the same. Now 50 will be no longer there. Again, as I mentioned on the slides, the point of contention between these two is that discard will give no error if I run it on something that does not exist in the set. So if I try to discard 40 again, it won't do anything because 40 is not there. But if I try to remove 40, it'll give me an error. So discard is a way to do it without returning an error. But of course, the error can be useful in some cases. But just keep in mind that there are two methods of doing so. So, oh, and just one last thing as well. Of course, I mentioned you can do pop and it'll just remove some random value. There's no order to it, so it'll just pop some arbitrary value. It just decided to pop 33. So yeah, that's all for sets. Are there any questions so far before we move on to our last data structure? Okay. Right. So the last thing we'll talk about today is dictionaries. So dictionaries are, of course, another useful form of storing data. And dictionaries will work a little bit differently now because instead of just having one value in each slot, dictionaries have key value pairs in each slot of your dictionary. And each key must be unique within each dictionary. So I can't have two mappings to the same key. It'll just simply update it with the latest version if I do it. And we'll see what I mean by update and how you would do so. So just one thing to note, dictionaries can be iterated over, meaning you can use a for loop to print out each of the items in the dictionary. But since they use keys, they can't be easily indexed, which is why they're not sequences. There's actually, this is just like a side note, there was actually an update to dictionaries within the version 3.7 that does put dictionaries in order. Before then there was not. So the dictionaries we'll see now are actually ordered in the way that you insert them. But just think of them, the reason they're not sequences is because number one, historically they weren't in order, but number two, also they can't be easily indexed because they're all just key value pairs. So that was just like an aside. Keys that you have within the dictionary can be of any immutable data type. So something like a list that is mutable cannot be used as a key. And with all the data structures that we've gone through, you can have dictionaries with mixed types for keys. So you can have a key that's a string and then a key that's an int, all within the same dictionary. Okay, so how do we start creating dictionaries? You can create a dictionary with the variable name and curly braces, so very similar to how sets are, and you can add them one by one, or you can put some initial key value pairs into the dictionary within the curly braces. So just an example, so we have % of Hades completion. If you haven't played Hades before, it's just this really fun game, and I'm very bad at it. So even after 19 runs, I still have only completed 20%. But that's besides the point. We can have an empty dictionary to start with and do % of Hades completion and curly braces. Then every time I want to add a value, I use these brackets here. And the brackets just are where you put your key and you put the equal sign and then the value that you want it to have. If that key does not exist in the dictionary currently, it will be added. And so you'll see as I inserted run 1 and run 2 or run 19 with the values of 2 and 20 respectively. You can also do this as well, which is a little bit shorter. You just simply do % of Hades completion equals, and then curly braces, your key, and then we use colon to signify the pair and then the value after. And you'll usually see, whenever you see key value pairs written, oftentimes they will have the colon there to signify. So if you forget. Can the values of dictionaries vary in variable type as well? I believe they should be able to, yes. It's not restricted. We can try it in a little bit as well, just in an example. Mentors, feel free to correct me, but I'm pretty sure that you can have variable types. So with the examples that we went over, these will both result in the same dictionary. So you might see the curly braces and you may think, wait, but how does Python actually know the difference between a set and a dictionary if they're both using curly braces? And that's a pretty good question. So by default, doing something like my variable equals curly braces will tell Python that you want to make a dictionary. The way to create an empty set is by doing my variable equals set and with parentheses, which is why I mentioned it in a previous slide. But just to clarify, if you do my variable equals curly braces, by default, Python will see that as a dictionary. So of course, dictionaries also have some operations on it that you can do. One cool thing that you might want to do is actually sort your dictionary. So you can do sorted and then the dictionary name to sort the dictionary by its key. And adding new items, as we saw with the Hades example, can be done by doing the dictionary name and then the brackets and then some key name that you want, some new key name. Again, you can't have the same key repeated multiple times, and then it equals some value. And if you want to retrieve the values, meaning I want to see what's in my dictionary by key, of course, again, you have to look it up by key. Dictionaries do not have an index. So I can do dictionary name and then in brackets the key that I want to look for, or I can use the dictionary name .get and in parentheses the key I want to look for. And by retrieving the value, it will do the value out of the key value pair, of course. And kind of similar to how we had discard and remove, they are different ways of doing it, but one of them will result in an error. So with brackets, you will get an error if that key does not exist in your dictionary. While if you use get on a key that does not exist in that dictionary, you'll just return none. And if you remember from last time, none just means nothing. It's like null in other languages. So again, some more dictionary operations. You can update items by doing the dictionary name, brackets, and in brackets, whatever key you want to update, and then the updated value on the right. Recall that this is how you would make new entries into your dictionary, but because there cannot be repeats, this is how you would update the value. And of course, you can also delete items from a dictionary by either doing pop in the key name And just as a note, this will give an error if that does not exist. You can do pop item, and this will remove the last item that was inserted. And as I mentioned before, in like an aside, before version 3.7, it popped a random item. But if you're using the latest version, you can ensure that it will pop the last item that was inserted. You may also do .clear to wipe the entire dictionary. So just do the dictionary name, .clear with parentheses, and all the values will disappear. Actually, before I get into examples, because I've been talking for quite a while, do you guys have any questions about dictionaries at all? Okay. As always, feel free to drop questions in chat as they come up. Oh, whoa, okay, we're not done yet. We still have some more work to do. So let's open some new lines to separate, and let's start with dictionaries. So just before I go in, you'll find that a lot of these data structures work very similarly, but the point that's different about them is how they're actually stored. And when you decide which one you want to use in each situation, you'll base it off how it's stored, how easy it is to do certain things, i.e. indexing and whatnot. But again, just an aside. So let's start, all right? So let's make a dictionary of numbers. And this is a great application of it since you have key value pairs, so I can map some numbers to a name. So let's add Kesha, because I'm besties with Kesha, and just let's, I'm not gonna put her real number because I don't want you guys stalking her, but all right. So again, remember we put the key, then the colon and value. You can have mixed key types, you can have mixed value types, but just for simplicity's sake for this example, I'll just do string to number, so name to a number. All right, and if we print BFF nums, we'll see that they're just as I put them in, the name, colon, the value. I showed this earlier, but we can also do sorted and then do BFF num. Oh, that's not the name. BFF nums, and it'll put it in. It'll sort the keys and output that. So, for example, I put this in alphabetical order where DJ Khaled is first and Kesha second. Just like with sets and with sequences, we can also use the in operator to check using the key. So let's just do Kesha in BFF nums, and we'll see it's true. But if I do something like Britney Spears in BFF nums, I wish I had her number, but I don't, so it'll be false. All right. So let's get into some of the stuff I covered, such as adding something to a dictionary. So of course, we start with the dictionary name, and then in brackets, we put the key that we want. So I just got Gordon's number. And then I put the value that I want this new key value pair to have. So we'll just put some number. And if I print BFF nums, we'll see that Gordon Ramsay has now been added to the dictionary. So that's how you add them. How about getting the numbers or getting the different keys and values? So there's two ways to do it, as I mentioned. And I'm just going to put them in print statements. So if I do BFF underscore nums, I can use the brackets to get the key if it exists. So Kesha. And it'll print the value out. Whereas I can also do BFF nums.get Kesha. And it will, oopsies, sorry. I forgot to put the closing parentheses there. But I can also do that and it'll print the same number. Just as before, if I try to get some values such as Britney Spears with the braces, so if I just do it, I'll just do it real quick. So if I do Britney Spears, the brackets will give me an error, whereas if I do get with Britney Spears, I'll get none. So again, just two ways of doing the same thing. You could say you're adding another one to DJ Khaled. Yeah. Okay. So let's try Let's try updating the values. So I have Kesha's number, but Kesha had to. Well, let me just print it out so we can use it for comparison. But let's say Kesha had to change her number because people are just trying to get her number, man. Leave her alone. So let's change it. You can update it really similarly to how you add values into a dictionary. So again, I use brackets, and then I do equal sign and then her new number. So let's just do that. And if I print it, we'll see that the value was updated. Another thing we can do is delete stuff from this dictionary, of course. So there's different ways to do it, as I mentioned. So I'm just gonna make a new dictionary now because I don't want to lose my friends' numbers, to be honest. It'd be kind of hard getting it back. So let's just make a new dictionary. And this time I'll just map them to some numbers. So I'll have Bingus. If you don't know who Bingus is, you should look it up. It's not bad. It's just a cat meme. That's all. And then we'll do 4 to Python, and then we'll do 9 to woof woof. I like dogs. They're cute. They don't really have. I don't really have like a rhyme or reason to the numbers I put, but I just want to demonstrate that you can mix and match. All right. So now I have some dictionary with these names in it mapped to some number. Now, the ways to delete stuff from a list, a couple ways. One thing I can do is dictionary, and I'm just going to click tab to autofill. I can do .pop and put the value, put the key for the key value pair that I want to get rid of. So I'm just going to get rid of Python. Sorry, great language, but scared of the animal. So I'm just going to pop it. Just like pop with our stacks and queues, it will give back a value that you can store into a variable. Okay, that's one way to do it. Or you can do pop item. And what pop item does, if we see here, it'll just pop the last entry that was in the dictionary. Again, another thing, now that dictionaries are ordered ever since 3.7, it just pops the last item in the last item that was inserted. Before it would just pop some arbitrary value, but now we know that it will pop the last item that was inserted. So that's pop item. Honestly, I'm just going to reinitialize this dictionary just so I can show you how like the different deletions work. But so I'm just going to bring this back again, and let's just do dictionary and print that out just so you know we have those back. And let's say I just don't want this dictionary anymore. I can just do dictionary and do .clear, and all of those will be wiped away. If I print it, now we'll have an empty dictionary. Right. So those are some things that you can do with dictionaries. Of course, just as a note again, there's many different applications for it, and there are more functions and operations that you can do. But just as a basic overview, this is how dictionaries work. You'll see that with the operations, they're very similar to each other. And that really helps when you're implementing them so that you don't get too confused between a bunch of different functions. So that's all we have for this session. Thank you so much for coming, and thank you so much for attending and staying. Our next session will be next week, same time, 6 p.m. to 8 p.m. PST. Next time we'll be going over classes and inheritance. And just again, please feel free to fill out our feedback form. We really appreciate any and all feedback. Helps us improve our workshops and make sure we're presenting the information in the best way possible. And of course, there is a raffle at the end, so fill it out. And yeah, that's all. Thank you so much, guys. I exit out of the music, so I can't play it again, but yeah, that's it.